Today we are going to talk about the laws of falling bodies, and by the laws of falling bodies we refer to the scientist Galileo Galilei. Now, Mr. Galileo sent out three fundamental laws of falling bodies, and what are they? Well, the first law of falling bodies as described by scientist Galileo states that in a vacuum all the freely falling bodies starting from rest traverse equal distance in equal time. Now, an explanation for this law would be if there are two buildings of equal height and at the same time t, let us consider that the balls are falling from the same height h of these two buildings at the same time. So we can say that they will traverse equal distance in equal time, which means that after time t1, the traverse distance by both of the balls, which is h1 and h2, will be equal to each other. Alright, so the second law of Mr. Galileo states that starting from rest, the velocity of a freely falling body is proportional to the time taken to fall. Now, mathematically, we can say that the velocity v is proportional to t. T is the time taken. Alright, so what does this actually mean? Now let us consider again the example of that ball that we consider for the first law, that it is falling from a certain height. Now, after each and every single second that passes by for the ball falling from the height h, it acquires a certain velocity due to the gravitational attraction of the earth. So we can say that after time t1, if the ball acquires a velocity of v1 and after time t2 it acquires a velocity of v2, so we can say that v1 is proportional to t1 and v2 is proportional to t2. And for both the cases, we can say that v1 is equal to k times t1, where k is the proportionality constant, and v2 is equal to k times t2, where k is the proportionality constant as well. And since for both the cases k, which means that the constants are the same, we can just divide the two equations 1 and 2, and we can come to the conclusion that v1 over v2 is t1 over t2. And this is the relationship between the velocities acquired by a freely falling body from rest in a vacuum. And this is what the second law of Mr. Galileo says. Alright, moving on with the third law. The third law of Galileo says that starting from rest, the distance traversed by a freely falling body is proportional to the square of the time of the fall. And mathematically, we can say that the traverse distance h is proportional to the square of the time taken, which is denoted by t, of course. Alright, what would be a correct mathematical example? Well, let us again consider the example of the very ball that we considered in law 2, that it is falling from a certain height of h. Well, as time passes by, let us consider that after time t1, it has traversed a distance of h1, and after time t2, it has traversed a distance of h2. So again, we can say that according to the third law, that h1 is proportional to t1 squared and h2 is proportional to t2 squared. And then again, from here we can say that h1 is equal to k times t1 squared, where k is the proportionality constant, and h2 is equal to k times t2 squared, where k is again the proportionality constant. And we divide equation 1 by 2, and we get that h1 over h2 is equal to t1 squared over t2 squared, since the k's cancelled each other off. And we can write this as h1 over h2 is equal to t1 over t2 whole squared. So this is the mathematical explanation of the three laws of Galileo. So according to the three laws given over here, we can come to the equations of freely falling bodies. Well, if you have a good grip over the four equations of motion for bodies that move across a horizontal distance, which we have discussed previously in our lectures, then you will have a good concept of the equations for freely falling bodies as well, since they are v is u plus gt, h is ut plus half gt squared, and finally v squared is u squared plus 2gh. Aren't these similar to those that we have studied in our previous lectures? Well, yes, of course they are. But here is the catch. Well, for a body freely falling from rest from a given height to the ground, g over here is positive. So you use the positive value over here. But if a ball or a body is going from the ground towards the sky, or it is being launched from the ground, we consider the negative value for g, because the gravitational attraction is pulling the ball towards the center of the earth. So over here we consider the negative value for the freely falling body. Alright. Then comes the concept of maximum height and time of flight. We will come to a brief description and some of the derivations for the respective equations for these variables. Alright, what are maximum height and time of flight? Well, when a projectile is launched vertically from the ground, let's say that this is a ball, the projectile that we are considering, it is being launched from the ground towards the sky. Well, the maximum height achieved by the projectile is basically what? H max, or the maximum height. Alright, if this is the maximum height, then we can consider that the time taken for the ball to reach maximum height and return back to its initial position is basically the time taken, or the time of flight. Alright, so how do we come to a general equation that describes the motion of a particle of a freely falling body that has a particular h max and time of flight? Well, let us consider first for h max. Well, for h max, let us consider that the ball has been launched with an initial velocity of u, and at maximum height, the final velocity of the ball is v. And of course, at h max, which is the maximum height, the final velocity is 0. So, we can say that we can use the equation v squared is equal to u squared plus 2gh to derive an equation that describes the h max, or the maximum height, for the projectile. Now, we considered that for h max, the final velocity v is 0. So we can say from this equation that 0 squared is equal to u squared minus 2gh max. Since we are considering that the ball is moving upwards, we are using the conventional sign of what? Minus over here and not plus. And doing a bit of an algebra, we can say that u squared is equal to 2gh max, and h max is basically what? u squared over 2g. And this is what the equation for h max is for a projectile launched vertically upwards. Moving on with the concept of time of flight. We again consider the case for the ball that has been launched from the ground with a certain velocity of what? U. And it has achieved a maximum height of h max. Needless to say, at h max, the final velocity v is equal to what? 0. Alright, now we consider that for the ball to climb up to reach the maximum height h max, the time taken be t1. So we can use the equation that v is equal to what? U minus gt for the ball to go up, where of course t is basically t1 because it is going up. So we can say that since v is basically what? 0, so we can say that t1 is basically what? U over g. And for the ball to come down, the time taken is t2. So we consider that the initial velocity is what? 0. And the final velocity is what? U. So we can say that the final velocity is u and initial velocity is 0 plus g times t2. So we can solve for t2 over here, and t2 is basically what? U over g. So we can say that the time required for the ball to go up and the time required to come down for the ball have both been calculated as from 1 and from 2. So we can basically add these two equations up. This is basically time of flight, and we can say that t, time of flight, is basically what? U over g plus u over g is equal to what? 2u over g. So time of flight t is equal to 2u over g. And this is a general equation for the time of flight for a projectile launched vertically upwards. Well, that's all for now.